Hey everyone, and welcome back to the channel. So far, we've learned how to store single pieces of data in variables, we learned that a string is a sequence of characters, and we learned how to use loops to go through a sequence. But what about real-world data? Real-world data is rarely just one thing, it's connected. Think about a contact in your phone. You don't just have a name, you have a name and a phone number. You have an email address and a contact photo. How do we store this related data? We need a structure that links one piece of data, the label, to another, the value. That structure is the Python dictionary, and it's arguably the most important, most useful data structure you will learn. Let's get into it. A dictionary is a collection of key-value pairs. It's just like a real-world dictionary. You look up a key, the word, to get its value, the definition. The important rules are, keys must be unique. You can't have two entries for the same word. Keys must be immutable, meaning cannot be changed. This means you'll almost always use strings as your keys. And values can be anything, a string, a number, a boolean, a list, or even another dictionary. Let's make a dictionary that describes a user. We use curly braces to create one. Look at this structure. Username is the key, a string, and coder123 is its value. They are separated by a colon. Each pair is separated by a comma. And look at our values. We have a string, an integer, 28, a boolean, false, and even a list of strings. This is incredibly flexible. One quick note. In the past, dictionaries were unordered. Now, in modern Python, they remember the order you inserted things. But the real power isn't the order. It's the direct access using a key.
So how do we get data out of it? Unlike a string or a list, we don't use a number index like 0 or 1, we use the key. Using our user profile dictionary, let's get the username and age. We use square brackets, and put the key inside. This is great, but it has one big danger. What if I ask for a key that doesn't exist? What if I ask for location? Our program crashes with a key error. That's bad. Luckily, there's a safer way to get data, the .get method. See? No crash. .get location looked for the key, didn't find it, and just returned none, which is Python's special value for nothing. Even better, you can give .get a second argument, a default value to use if the key is missing. Okay, what about changing the dictionary? This is easy. Dictionaries are mutable, meaning changeable. It's the same syntax. My dict, bracket, key, bracket, equals value. If the key doesn't exist, it's created. If the key does exist, its value is updated. And to delete, we use the del keyword. Just like that, isAdmin is gone. You now know how to create, read, update, and delete data. This is called CRUD, and it's a fundamental concept in all of programming.
We learned for loops to go through sequences. How do we loop over a dictionary? We have a few options, but one is clearly the best. Let's use our user dictionary. What happens if we just loop over it directly? By default, a for loop over a dictionary gives you the keys. This is useful because inside the loop you can use the key to get the value. That works. But what if you only care about the values? You can use the .values method. But here it is, the best, cleanest, most Pythonic way to loop over a dictionary. It's the .items method. It gives you both the key and the value at the same time. Look at that for loop, for key, comma, value. We're getting two variables for each item. This is so clean and readable.
Now let's learn the next major built-in data structure, the set. So what is a set? A set is a collection, just like a list, but it has two very special, very powerful properties. It is unordered. This means the items have no index, no position, no first or second item. It only stores unique items. It cannot contain duplicates. If you ever need to find unique items or compare two collections with lightning speed, sets are your secret weapon. Let's find out why. Creating a set looks a lot like a dictionary, but with a critical difference. You use curly braces, but you just put the items inside, separated by commas. Let's make a set of numbers. Look at that. Python automatically removed all the duplicates for us. This is the main superpower of a set. Also, notice the order might not be the same one we typed. Sets are unordered. You can also easily create a set from a list. I have to show you the #1 beginner trap. How do you make an empty set? You probably think it's curly braces, right? Wrong. Remember, curly braces is an empty dictionary. Set is an empty set. Don't forget this.
Sets are mutable, which means we can change them. But since they're unordered, you can't update an item. You just add or remove items. Let's start with our unique fruits set. To add an item, we use the .add method. See, it added grape just fine. But when we tried to add apple again, it just did nothing. No error. It just ignored the duplicate. Now for removing, we have two options. Just like with dictionaries, one is safe, one is not. .remove will crash your program with a key error if the item isn't there. A much safer way is .discard. If the item is there, it removes it. If it's not there, it does nothing. No crash. My advice, almost always use .discard unless you specifically want your program to crash if the item is missing. Looping over a set is easy. It's just a standard for loop. For fruit in unique fruits. Just remember, there's no guaranteed order. But the real magic is membership testing with the in keyword. When you check if item in my list, Python has to look at every single item one by one. If your list has a billion items, that's a billion checks. But a set is different. It uses a super smart lookup called a hash table, just like dictionaries. It can find an item almost instantly. The takeaway? If your main goal is to store unique items just to check if something exists, a set is thousands of times faster than a list. Okay, this is the original purpose of sets. They let you do set theory from math class, but it's super practical. Let's imagine we have two groups of users. Let's say we have users who like Python and users who like JavaScript. First, what if we want a list of all developers with no duplicates? We want the union.
Awesome. Now what if we want to know who is a full-stack developer, who is in both sets? We want the intersection. Finally, what if we want to know who only likes Python but not JavaScript? We want the difference. And just to be complete, what about the JavaScript-only devs?
The final piece of the puzzle, the tuple. So, what is a tuple? The easiest way to think of it is as a list that cannot be changed. It's an ordered collection, like a list, but it's immutable, meaning unchangeable once it's created. You might be thinking, why would I want a list I can't change? Well, it turns out this limitation is actually a superpower. Let's find out why. Let's see this in action. The syntax is the first clue. Lists use square brackets. Tuples use parentheses. Let's make a list and a tuple side by side holding the same data. So far, so good. And because they're both ordered, we can access items using an index, just like a list. We can also loop over them in the exact same way. But here is the all-important difference. Let's try to change the first item in our list. No problem. Lists are mutable. Now, let's try to do the exact same thing to our tuple.
And there it is, a type error. Python is stopping us. It's saying, this is a tuple, you are not allowed to change it. The same thing happens if we try to .append or .pop. Those methods don't even exist for tuples. This is the core concept. A list is a box of things you can change, add to, or remove from. A tuple is a sealed, transparent box. You can see what's inside, but you can't touch it.
Okay, I have to show you one weird syntax trap. How do you make a tuple with only one item? You'd think it's this, right? Not a tuple equals parentheses 1. But if you check the type, that's an integer. Python just sees the parentheses as standard math parentheses, like parentheses 1 plus 2. To tell Python you really mean a one-item tuple, you have to add a trailing comma. I know, it looks weird, but parentheses 1, comma, is a tuple, parentheses 1 is a number. You'll get caught by this one day, so remember the comma. Okay, so why bother? Why not just use a list and not change it? Reason 1, data integrity and safety. Sometimes you want to guarantee that data can't be changed. Reason 2, performance. This is a minor one, but because Python knows a tuple's size will never change, it can be slightly faster and more memory efficient than a list. Reason 3, this is the big one. Tuples can be used as dictionary keys. In our dictionary lesson, I said keys must be immutable. What happens if we try to use our MyList as a dictionary key? Another type error. Python says you can't use a list as a key because it's mutable. It could change. But what about our immutable tuple? This is a huge use case. If you need to map a pair of values like coordinates to a single value like a city name, a tuple is your only choice for the key. Okay, we've saved the best for last. Tuples are central to one of Python's coolest and most useful features, unpacking. We have a tuple with two items. What if we want to assign those items to two separate variables? The long way would be this. But the Pythonic way is tuple unpacking. Watch this. Do you realize what this means? You've already been doing this. Remember in the dictionary lesson when we did this? Where did K and V come from? The .items method returns a list of tuples. This is also how functions in Python return multiple values. They're just returning a single tuple, which you then unpack. So, are tuples just broken lists? No, they are an intentional, powerful tool for writing safe, fast, and clean Python. You use them when you know your data shouldn't change, when you need a dictionary key for multiple items, and you use their unpacking power every single day. We have now officially mastered all of Python's core data types. We know how to store data, make decisions, and loop. It is finally time to organize our code into clean, reusable blocks. In our next video, we build functions. If this video helped you, please hit that like button, subscribe for more, and leave a comment with your homework. Keep practicing, and I'll see you in the next one. Happy coding!